Welcome to The Explainer. Today, we're unpacking some fascinating research that details what is essentially a microscopic heist. We're going to look at how scientists are using a revolutionary green chemistry technique, specifically supramolecular deep eutectic solvents, to hunt down toxic melamine hiding out in a common, everyday product, milk.
Now, it almost sounds like the setup to a riddle, right? How do you find a microscopic drop of poison in a glass of milk? Melamine is a highly dangerous adulterant, but finding trace amounts of it hidden inside a messy, complex matrix of milk fats and proteins, yeah, that's incredibly difficult. You can't just look for it. You literally have to extract it perfectly. So, here's our agenda for today. We're covering the hidden melamine danger, meet the green solvents, Step 1, matrix pretreatment, Step 2, the microextraction, the beta-cyclodextrin secret weapon, and high-efficiency, low-impact. Let's dive right in.
Section 1. The hidden melamine danger inside the vault.
So, melamine is a nitrogen-rich chemical, and because standard tests for protein actually just measure nitrogen levels, bad actors have historically added melamine to make diluted milk appear protein-rich. This tragically caused the 2008 Chinese milk scandal, where prolonged intake caused severe renal failure in infants. Today, global regulatory bodies like the FDA set absolutely strict limits, as low as 1 milligram per kilogram in powdered infant formula. But pulling such tiny, elusive amounts out of milk, which is a complex biological matrix heavily guarded by interfering proteins and fats, is a massive analytical challenge.
Moving on to Section 2. Meet the green solvents, the heist crew.
To pull off this precise microscopic extraction, researchers couldn't just use brute force, right? They needed to assemble a specialized, highly coordinated, non-toxic crew. And that brings us to SUPRADES. Instead of toxic traditional solvents or energy-heavy machines, this method brilliantly leverages supramolecular deep eutectic solvents. Basically, these are a novel, eco-friendly class of liquids that self-assemble. By shifting hydrogen bonds, these natural components combine to create a liquid that can encapsulate targets and pull off complex chemical extractions at room temperature. And the best part? All of this happens without needing any external energy input like a heavy laboratory sonicator. Our SUPRADES crew basically has two main players working in tandem. First, we've got the hydrophobic extraction solvent. It's made of thymol and non-anoic acid, and its sole job is to isolate and grab the target melamine. Then we have the hydrophilic disperser solvent, made of choline chloride and ethylene glycol. Since milk is mostly water, this hydrophilic disperser acts as a sort of delivery vehicle. It perfectly spreads the hydrophobic extraction solvent throughout the milk to track down that melamine. Section 3. Step 1. Matrix pretreatment, bypassing security. You see, if you don't remove the proteins first, they're going to completely interfere with the extraction. So, the researchers add exactly 500 milligrams of anhydrous sodium sulfate to 5 milliliters of milk. By stirring this and then spinning it down in a centrifuge, they trigger a salting out effect. Basically, those highly charged sulfate anions force the interfering proteins to clump up and just drop out of the solution. That leaves a totally clear path for our solvents without letting the milk fats ruin the whole process. Which brings us to Section 4. Step 2. The microextraction, the infiltration.
Now this is the absolute core of the dispersive liquid-liquid microextraction, or DLLME. Step 1 is absolutely crucial. The milk is neutralized strictly to a pH of 7.0. Why? Well, because at this exact neutral pH, melamine shifts into a molecular form, making it super eager to jump right into our organic extraction solvent. Next, researchers rapidly inject the prepared SUPRADES mixture directly into the milk. Instantly, a fine, cloudy emulsion forms. Thanks to this massive dispersion, it takes just 1 single minute for the solvent to fully capture the melamine before it's spun down in a centrifuge for collection.
Section 5. The beta-cyclodextrin secret weapon, supercharging the solvents.
So, we just mentioned that the extraction happens incredibly fast by forming a cloudy emulsion. But what's the actual mastermind making that rapid infiltration possible? The answer is an oligosaccharide called beta-cyclodextrin. When researchers added just 1% of this into the disperser solvent, the extraction solvent droplet size absolutely plummeted. I mean, we're talking a drop from over 33 micrometers down to a microscopic 6.54 micrometers. It's a real game changer.
And this brilliantly illustrates a fundamental rule of chemistry. A massive reduction in droplet size multiplies your surface area.
You see, beta-cyclodextrin has a hydrophilic exterior and a hydrophobic inner cavity. It stabilizes the emulsion, creating this immense contact area between the milk and the extraction solvent. This is exactly how the green solvents could just swallow up the melamine in a single minute without needing the heavy external energy input that those older traditional methods require.
Section 6. High efficiency, low impact, the escape and verification.
Okay, so the heist is pulled off. But you know, in analytical chemistry, you always have to prove your work. To confirm the chemistry was actually doing what we think, researchers used FTIR analysis. If you look at those jagged lines, you can see shifts representing the OH and CO stretching vibrations. This is hard proof that natural components like thymol and nonanoic acid successfully broke their own hydrogen bonds and reorganized themselves to form our new unified deep eutectic extraction solvent.
And I have to say, the extraction results are just undeniable. When researchers tested this method by spiking milk with 200, 500, and 800 nanograms per milliliter of melamine, the recovery rates were stunning. They achieved between a 92% and 107% recovery rate. That means practically all the melamine was successfully extracted from the vial. And with a relative standard deviation of less than 5%, the precision is just exceptional.
But here's what really makes this a breakthrough. Not only is the process blazing fast, taking only 6 minutes for the whole extraction, but it avoids toxic organic solvents entirely. It's incredibly sensitive too. It can quantify melamine at just 81 nanograms per milliliter, which is well below those strict FDA limits. Because of all this, it earned an impressive 79 out of 100 on the Advanced Green Chemistry Index. It proves, for sure, that we don't have to sacrifice the planet just to ensure our food supply is safe.
By engineering a smart, supramolecular team of eco-friendly chemicals, scientists have found a way to outsmart a complex matrix and trap a highly dangerous adulterant. So, the final thought I want to leave you with today is this. If nature-inspired solvents can flawlessly execute a microscopic heist on something as elusive as melamine, what other hidden dangers could they help us uncover next? Thanks for joining me for this explainer. Keep questioning and keep learning.